Hello everyone, let's learn how to solve the problem on the board. So we have this nice looking static exponential expression from Stanford University entrance exam math problem. So we have 2 to the power of 101 plus 8 all upon 16 to the power of 13 plus 4 to the power of 14 plus 8. As you can see, all the base numbers can be expressed in 2. Then I'm also going to use 2 intricate laws of exponent. The first one is the one I call the reverse product rule. If I have a to the power of m plus n, this is a to the power of m multiply a to the power of n. You know from the multiplication rule, if 2 or more base numbers with the same or different exponents, we add the exponents. So if you move from front to back, you will see that it's a reverse product rule. Then we also know that if I have a to the m, then all to the n. This is the same thing as a to the mn. So this is the power rule. So here we have 2 to the power of 101. Then 8 is 2 cubed. All upon 16 is 2 to the 4th. So we have 2 to the 4th all to the 13th. Then 4 is 2 squared. I will have 2 squared to the 14th. Then plus 8, which is 2 cubed. So I will then use the power rule. So we are going to be having 2 to the power of 101 plus 2 to the power of 3 upon, at the denominator, we are going to be having 4 times 13, which is 52. Plus, here, 2 times 14, that will be 28. Then plus 2 cubed. The next thing we shall do again is to find a way to factorize the greatest common factor. As you can see, 2 to the 3rd or 2 cubed is inside 2 to the 101, and the others 2 to the 52, 2 to the 28. So 2 cubed is actually inside all these numbers. And now we know that 101 is same thing as 98 plus 3. So 28 is also the same thing as 25 plus 3. Then 52 is 49 plus 3. So I can then write this expression to be 2 to the power of 98 plus 3 plus 2 cubed all upon, in place of 52, I shall use 49 plus 3. Then we have 2 to the power of 49 plus 3. Then 28, I will use 25 plus 3. So we have 2 to the power of 25 plus 3, then plus 2 cubed. The next thing is this. I will use the reverse product rule to split this expression. So we will be having 2 to the power of 98 multiply 2 cubed. So you can see what we are trying to do here, plus 2 cubed all upon 2 to the power of 49 times 2 cubed plus 2 to the power of 25 times 2 cubed plus 2 cubed. Can you see this? This is interesting. So from what we have done here, I can then factor out 2 cubed on the numerator and the denominator respectively. So this is going to give me 2 cubed. I'll open a parenthesis. 2 cubed divide this term. 2 to the power of 98 multiply 2 cubed. 2 to the power of 98 is left. 2 cubed divide itself, that becomes 1. Then at the denominator, I will do the same. Factor out 2 cubed, open a parenthesis. 2 cubed divide this term. 2 to the power of 49 is left. All right. 2 to the power of 49. Then if I do the same thing with this guy here, 2 cubed will go. We have 2 to the power of 25. Then 2 cubed divide 2 cubed. That will give us 1. As you can see, 2 cubed will annihilate 2 cubed. So we are then going to be having a final expression which can be solved using algebra. And we shall do that. There is no chance in hell for the average-minded person to simplify this, except the likes of Einstein and Stephen Wolfram. We have to the power of 98 plus 1 all upon to the power of 49 plus to the power of 25 plus 1. Like I said, it will take only a genius to be able to factorize it. So, therefore, we shall switch to algebra. I will say let S equals to the power of 25. Then 2 to the power of 49, I can write that to be 2 to the power of 50 plus 1. No, minus 1, sorry. Then, by the division rule of exponent, I can also reverse this. This is something as 2 to the power of 50 divided by 2 to the power of 1, which is something as 2. Then, I can also write this again to be 2 to the power of 25 whole square divided by 2. So guys, as you can see, 2 to the power of 25 is x. So we are going to be having s squared upon 2. Can you see this? Very interesting. So you have to watch this video to the end. Then we can then say, okay, 2 to the power of 98, that's going to be 2 to the power of 49 whole squared. And this is going to give us s squared upon 2 whole square. And this is going to give us s to the fourth upon 4. Okay, then I can then rewrite the expression we have here on the numerator. It's a nice problem with a very beautiful solution as usual. You know, the mandate is to make mathematics simpler again. Okay, then to the power of 98, I'll plug in s to the fourth upon 4 plus 1. I'm now using algebra. Try to make a nice substitutions. And to the power of 49, that's s squared upon 2. I'll say s squared upon 2. To the power of 25, that's x. Then plus 1. Now, first and foremost, I have to get rid of the fractions by multiplying both the numerator and denominator by the lowest common multiple, which is 4. So I'll be having s to the fourth plus 4. If I multiply every term here by 4, I'm going to be having 2s squared plus 4s plus 4. This is going on extremely well. The next thing we shall do is how do we take care of this? This is where creativity has to come in. Logical reasoning. I have to find a way to make the numerator a perfect square by injecting a factor into this expression. So that's going to give us s to the fourth plus 4s squared plus 4. This is the factor I'm introducing so that I can factorize. That's the reason why algebra is very interesting. Then I will subtract the same factor, which is 4s squared, all upon 2s squared plus 4s plus 4. So guys, 4s squared is a perfect square or a square number which is 2s squared. Then s to the fourth plus 4s squared plus 4 is also a perfect square, which is s squared plus 2 all squared. So I can then write s squared plus 2 whole squared minus 2s whole squared all upon, I'll factorize the denominator, factor out 2, we're having s squared plus 2s plus 2. So guys, on the numerator, we have a difference of 2 squares, a very famous algebraic identity. So we know that a squared minus b squared is equal to a plus b, then a minus b. Now our A is s squared plus 2. Our A is s squared plus 2. Our B is equal to 2x. So let's use this to take care of the numerator and clean it up. So that's the very last lap of this problem. So if we do that, okay, A is s squared plus 2, B is 2s. So A plus B, which is the first parenthesis here, will give me s squared plus 2s plus 2 in one parenthesis. Then the second parenthesis is A minus B. So that's going to be s squared minus 2s plus 2 all upon 2 into s squared plus 2s plus 2. So guys, this is quite interesting. The answer is staring at us. So you can see that these parentheses will take out these parentheses. We are only left with s squared minus 2x plus 2 all upon 2. So if I decide to use the denominator, which is number 2, to divide every term on the numerator, I will have a final expression. S squared upon 2 minus 2s divided by 2, that will give me x. Then 2 divided by 2, that will give me 1. And I know that s is 2 to the power of 25. And I also know that s squared upon 2 is 2 to the power of 49. So I can decide to say this is 2 to the power of 49 minus 2 to the power of 25, which is x, plus 1. So this is the final simplified solution to this problem. So guys, please ensure you like and share this video. Also put a comment and make sure you subscribe to join this community by turning on the post notification so that you wouldn't miss out in our upcoming videos. See you next time and God bless you.